Hi guys, for today's lesson we're going to be dealing with differentiation using the chain rule. So what do I mean by this? What is the chain rule? So it's a technique used to differentiate functions where multiple terms are powered. So this is the formula. So dy dx is what we're trying to find. That's the derivative of our function. And that is going to be equal to dy du multiplied by du dx. So the idea is that we're introducing a new variable called u. And we're differentiating in terms of u. So pretty much instead of an x, it's a u. And we're also taking whatever u is equal to and we're differentiating it in terms of x. So hopefully an example will clear up any confusion. So for example, if y is equal to 5 lots of 2x plus 3 all to the power of 4, first up we look at this and we think to ourselves, this is a bit of a problem sort of question to differentiate, and the idea is that this 2x plus 3 is being powered to 4. We can't expand this bracket because this power of 4 is too large. Well, you could, but it would take a long time to expand this bracket. So we want to use the chain rule to kind of alleviate this issue that we've got here. Because typically we'd want to just move this forward to the front, but because it's powering multiple terms, it's not so simple. Okay, so step one, what we want to do is we want to let u equal these multiple terms, like this 2x plus 3. So we're introducing a new variable u. And step number 2 is to look at this and think, okay, let's differentiate u in terms of these x's. So if we differentiate this, which is u, the derivative of this is just going to be equal to 2, because the derivative of 2x is 2 and the derivative of 3 is 0. So we get that first part, which is part of our formula right there. And we want to get this part of our formula. We want to figure out what dy du is. So the idea is now is to pretty much use this original function, but we're going to change this to u because that's what it's equal to. So y becomes 5 lots of u to the power of 4, because that's literally just a u. It's this changing to this. And now that we know what y is equal to in terms of u, we can figure out dy du. So we just pretend that like that's an x and we differentiate as normal. This 4 multiplies by the 5 to get 20u to the power of 3. This power of 4 goes down to 1. So now that we've got du dx and dy du, our derivative is going to be equal to these two things multiplying together. So all we need to do is pretty much change our dy du to this, and our du dx to a 2. This is just the formula that I pulled from here. And that comes down, and we have to simplify this for our derivative, and that equals 40u cubed. Now, we don't want to leave our final answer with u's. We want to change our u back to what it was equal to. So u was equal to 2x plus 3. So that u is literally going to change to that, and there is our final answer. Another example is this. Notice that we've got x's on the denominator and in a square root, and there's multiple terms. So the main thing is that these multiple terms are creating us havoc. Well, first up, we don't like to deal with denominators and square root signs, so change this to index form. So it's going to be these two terms, x cubed plus x to the power of negative 1/2. And next up, we let u equal these multiple terms. So let u equal x cubed plus x. So we can find du dx, the first part of our formula, and that's going to be equal to this differentiated, which is 3x squared plus 1. Now, looking at this function here, our u has changed to this part, so it's going to be u to the power of negative 1/2. And differentiating this in terms of u, we get negative 1/2 out the front, and this goes down to negative 3 on 2, so that's our dy du. And remember, our formula means we just have to multiply these two things here. So when we do that, we've got these two things multiplying right here. We want to simplify this. So when we do that, we obviously want to get rid of our u straight away. And our u is going to change to what it's equal to in terms of x, and then suddenly we need to now simplify this expression. Now, this does look very messy, but the idea is we pretty much just going to change our negative powers to a denominator and also to a square root sign, because it's a fractional power. you'll notice that the negative half just stays out the front, -1 over 2, or just negative over 2. This part here can just stay in brackets up the top. And this thing here is square rooted, and this power of 3 powers those two terms inside the square root. So it is a bit messy, but that's the answer required. Don't worry too much about expanding the brackets, etc. We just want to get some sort of expression that looks half decent, and then we're done. Now I want to go over a quick method that will make this a little bit faster than going through all these steps. So the strategy is to move the power outside the bracket. So the one that's outside the bracket, you want to move that to the front of the bracket, just like you usually do with differentiation. Remember, that's multiplying at the front. And then you want to lower the power by 1. So that appears just normal differentiation. But because you've got multiple terms in some sort of bracket, you need to multiply your answer by the derivative of the expression inside the bracket. So we'll do another example, say this one here. So notice we've got multiple terms being powered. The quick method is just to move this power to the front. This power goes down by 1. Notice your bracket stays the same, but you need to make sure that you multiply by the derivative of your bracket. So the derivative of this is just going to be 3. So make sure on the end you just multiply by that 3. So 3 times 5 gives you 15. And you're done. So it's a nice fast method. EG2, if you've got this sort of thing here, remember we want to change this to index form, so it's going to be power of -1/2 here. The idea is just bring your power to the front, make your power go down by 1, and you just have to multiply by the derivative of this bracket, which is going to be 10x to the power of 4, take away 1. So 10x to the power of 4 take away 1 is just multiplying it. We like to have these nice simple brackets come more to the front, so it's going to just become behind this -1/2. This thing here, -3 over 2, that definitely has to go to the denominator and has to become a square root. So and that 3 is going to still power those multiple terms, and we get this expression here. Notice again our -1/2 becomes a -over2. Up the top here, I thought it'd be a little bit better to expand this bracket, because that negative can go with this to make -10x to the power of 4, and this negative can go with the -1 to make a +1. So this just looks a little bit nicer than that, but either of these answers would be acceptable. Hope this helps with the questions. Good luck.